Okay, so this is from the book. This is section 4. Chapter 4 homework question. So let's look at number 103. Right? It says the literacy rate for a nation is people who cannot read. How bad is that? How sad is that? It says literacy rate is 28.1. That's bad. That means if you pick a random person in Afghanistan, I don't know what year it was written, there's about 28%, only 28.1% chance this person can read, right? So let's say I have 21 students in Afghanistan, and then I guess there are students that may be able to read. Let's say I have 21 like random people in Afghanistan, and then ask them, raise your hand if you're able to read. You see how it's kind of same situation. Either they're going to be yes or no, right? And here, each person, they have 28.1% chance that this person will say yes. So I want to see how many people are going to say yes, right? Do you see how it's very similar as do you like math question, right? So I'm going to try to count the number of people. So here, what we can do is, I'm going to look at part C. It says find the probability that more than 5 people. Here, I'm going to make it, I'm going to see part D. Find the probability that like 3 people are literate. So that means if I here, I'm asking 15 people and says, raise your hand if you can read, you're literate. I want to see probability that 3 people will raise their hand, right? It could be 5, it could be 2, right? I don't know. But I want to say it's 3. So what's going to happen? So I'm just making up my own question here, but I like the setup. So in this case, this is going to be, N is going to be 15 because we're serving 15 people, right? And then P is going to be 0.281. So it's not 0.5 here. It's not half and half chance. They say it's 28.1%, so it's 0.281. And I want to look at number of successes is 3, right? So if I were to use calculator, it'd be binom PDF. So binom PDF calculates probability of getting one, like a particular, like a number of people saying yes, right? So it could be 3, it could be 5. Here it says 3. I just made it up. So then I'm going to pick 15 for N, 0.281 for P, and then 3 for X. So if I input into the calculator, by the way, this is under second, oops. Bars, right? So binom CDF, number of trials 15, P is 0.281, and then 3. I got 0.193. So about 19.3% chance.
For binomial PDF, when you use that, it says there's a value for X, and then they went the mean and the standard deviation. Am I in the wrong?
No, that's not that's normal. You're looking at binom doesn't have a mean and the standard deviation.
Oh, that's why.
Here, let me try to project the calculator here and then see.
I got the same answer.
Yeah. Did my calculator expire? Let me see. Oh, yeah. Oh, I have 1 week left. Oh my gosh. I might have to purchase this. I don't even know how much it costs. I don't know. Here, let me project this screen here. So, okay. So here is under, can you see the calculator okay?
Yeah.
So it's going to be second vars under distribution. And we'll just scroll down to, so this is not normal, this is binomial, right? So I'm going to scroll down to binomial PDF. Oh, here, PDF. And number of trials, that's N, that's 15. Here I'm asking 15 students. P is 0.281. X value is number of successes. So I want to say 3 people, right? So if I have a class with 15 students, what's the probability that 3 people can read? Enter. It gives me 0.19 something something. Okay.
So how do you recognize a binomial problem though?
Binomial is there. The most important one is the answer you get is basically yes, no question.
Yes or no, okay.
Yeah. And then you're trying to count number of successes.
Okay.
Right. So here Afghan, either they're literate or illiterate, yes or no, right? And then you're going to try to count the number of people who are literate. You see that?
Yeah.
So that'll be my same here. Like number 102, I'm not going to actually do it, but just to recognize the like a type of question. So here, according to the World Bank, only 9% of the population of Uganda have access to electricity, right? And they survey 150 people. Basically, I want to find the probability that at most 10 people have electricity, right? So it's like you're looking at number of people who have access to electricity out of 150 people. You see that? So kind of same thing. I'm asking these people, raise your hand if you have electricity access. Bunch of yeses, bunch of nos out of 150 people of my class, right? So it's yes, no question. Either you have it or you don't. And I'm trying to count the number of people who have it. Like find the probability that more than 25. Find the probability that at most 10. I'm trying to look at probability of certain number of yeses. You see that?
Mm-hmm.
So then I know it's binomial question. Any other questions from the homework or worksheet?
Figure 67 on chapter 17.
67?
Yeah.
This one?
Yeah.
Okay. On average, 18 die from motor vehicle injury per day. Wait,
that's not the same question.
That's not the same question. Did I assign? This is from the book.
Yeah, from the book. Are you in the book?
Is it chapter 4 or 5?
7.
Chapters. Oh my gosh. Yeah, you said that. Oh, that's okay. That's our future. Okay. Okay. Six to 7. When the sample size is large, the mean of X bar is approaching because it's
I know those two are true, but see, I was wondering why B was true.
When sample size is large, X bar is above normal distribution. That's just strictly from central limit theorem.
Okay. Definition.
What that means is when you, so X bar is the sample means, right?
Mm-hmm.
So this is the kind of different topics, but when you go survey, let's say 30 people and ask for how much money they spend on textbook, right?
Mm-hmm.
When I go survey 30 people and ask them how much they money spend on textbook, right?
Mm-hmm.
So your survey and my survey, if I calculate the X bar sample mean, we're gonna have different answer, right?
Yeah.
But our answer, so let's say we all did it, like all of us in our class, right? So we're gonna get a bunch of numbers, right?
Mm-hmm.
Our number is gonna be just distributed differently, but what it turned out to be is if you look at the distribution of the answers we get, it's gonna be like normal distribution, meaning we're gonna have a bunch of us will have very similar numbers in like as an average.
Okay.
And some of us are gonna have some number that is way up, but not gonna be that much. You know, normal distribution, there's a lot in the middle and then not much at the end of the tail.
Mm-hmm.
So this is
What do they
basically-
mean by sample if the sample size is large? Like a lot
So
of people.
we have to
doing
do,
it?
we have to survey more than 30 people. If I just survey
yeah.
2 people, it's
Okay.
not gonna work like that. Yeah.
Yeah.
So that's what it means. Sample size is like how many people each person surveys. Like,
Can you look at 64D real fast? I just wanted to see how to find
the median age.
Yeah.
If you have a normal distribution, mean and the median is basically the same thing because it's the number right in the middle.
Okay.
So they could have asked, what's the mean average of age and running time?
Okay.
The same as median. Okay, then. So I'm gonna release the quiz at some point soon, right away now, almost now. And
Professor, I
then,
got a
yes,
quick question.
yeah.
On that practice quiz you gave us,
Okay, practice quiz, okay.
number 4.
Okay, here, let me bring in the, number 4.
It says, yeah. It says which is lower, right? So lower is
Oh,
the end.
yeah. The other way. I somehow I thought I asked higher. So, yes.
Okay, just making sure.
Yeah. I answered higher. So, sorry. So generally speaking, A and B will have fewer people in it, right? Than A or B.
Yeah.
If it's like A or B, then means you're including a lot of people.
Yeah.
If it's
that's-
A and B,
that's-
then you're not including that many people. So I will release the quiz. Yeah, and then we have our exam on Friday. So that's kind of similar. I'll update that. It's basically written part plus oral presentation. So that's gonna be what's gonna happen on Friday. It's including similar topics, but with normal distribution too. I'll put the more detailed. And then like on Thursday, I can do, Thursday, I'll have office hours. So I can, if you have questions, I can be available on Thursday.
Professor, I have a question about one of the worksheets.
Yes.
Worksheet number 16, number 9.
16, okay.
Or I just wanted to know like how to do that.
Number 9?
Yeah.
Okay. Like just pick one or is a particular one?
A.
Hey, so yeah. No, this is, so first of all, I noticed that they're using letter Z. This means normal distribution, standard normal distribution. Oops, standard. You know how when we talked about Z-score before, like to figure out like where you stand, like if 0 means your average, that's why it's 0 right here. If you go more than 2 z-score, that means your number is pretty high, right?
An outlier, right?
Yeah, outlier. So pretty similar concept, meaning like here's 2, here's -2. Like they're not much, notice they're not much here, right? So most of people are gonna be like in this section. That's like us, right? These two, there are not that many here. You don't have that much. So this is like normal distribution. Here, the question is asking z-score is between -1.12, so somewhere here maybe, and 2.05, 2.05 somewhere here. So they're looking for this area, right? So again, like this is probability distribution. So entire thing is 100%. So if you look at this, it's like, okay, I mean, it looks pretty good amount, right?
Yeah.
So my guess is like maybe 70%, 80%, something like that. But we can precisely calculate it. So we're gonna use the normal CDF function key. It's gonna ask for lower bound, upper bound, mu, and sigma. Again, what they mean by lower bound is, this is my area, right? Lower bound is basically the lowest number. Where does like, how far does it go to the lower part? It goes to -1.12, right? So -1.12. Upper part is 2.05. Sigma is 0, which, I mean, mu is 0. Mu is the mean, which is your, and sigma is 1.
So then, like in this case, since we have both of the numbers, like for example, in B, the lower would be like in the negative infinity, right?
Depends on how the graph is. So let's look at it. That's a good question. Part B. So part A, we have 2 numbers. So it's easy to just plug in these 2 numbers, right? Here it says Z is bigger than -1.23. Here, Z is bigger than this sign, like bigger side goes with the bigger number. So if I have A like this, this is big number, this is, oh, sorry. Like big number goes with the big side and the small number goes to the small side. So they say z-score is bigger than this number, right? In that case, is it to the left or is it to the right?
To the right.
To the right. Okay, good. Again, theoretically, this graph goes on forever. So I'm going to do this.
Oh, so the lower is
Exactly,
negative and then the
exactly.
upper. Okay, that's
Yep.
what I get confused. Which one's
Yeah.
upper?
So like for me too, so I have to kind of look at it graphically to see like, you know what I'm saying? So sometimes it'd be easier for me to see it as a graph. So it goes to infinity, so I put like 1,000,000. So if it doesn't stop, then theoretically it goes on forever. That means it's infinity. That means it's just like some big number.
Professor, what if it's the same thing, like like Z less than -1.23?
So if the question was like this part, right? Then -1,000,000
Okay, got it.
and positive -1.23 is the upper limit. So I'll just switch it. So left is to the negative side and then positive. This is like a negative side. This is like a positive side. Yeah.
So if it's positive, then the million would be always like upper, or
yeah.
no?
If it goes to, yeah. So if your graph looks like this, your upper is going to be just 1,000,000. I mean, it depends on like, it has to be like big enough number, so it's significantly bigger than like this part, right?
Gotcha.
What about question? Oh, sorry. After.
Go ahead. Go ahead. No, go ahead.
Also question 18 from worksheet 16.
Okay. Question 18. Where are you? 18. Okay. So this is pregnancy. So this is not like z-score anymore, but it's still normal. But they give you different mean and different standard deviation, right? So my graph is going to look different. The shape is going to be exactly the same, but like here, let me draw this like this. And So instead of putting 0 in the middle, I'm going to put 278 because average pregnancy is not 0 days, right? It doesn't make. And then standard deviation is 9.5. So I go by 9.5. So 287.5 to 9. Oh my gosh, I can't. 9.5 to 97, 306.5. Let me double check my answer. 278 plus 9.5. I wish I would do it like so easily. Now I have to use a calculator. I could have calculated. Okay. And so on and so forth. Then I'll subtract 9.5 each time. $259, 249.5. Is setup okay?
Yeah.
Any question on the setup? So this is the mean. Then I go by standard deviation. Okay. So what is the probability that a random and selected pregnancy lasts longer than 285 days? So 285 days is somewhere here, maybe? Is that right?
Yeah.
And it says more than that many days. So should I shade to the right or to the left or
To the right.
to the right, like this one? So again, theoretically, like your pregnancy can last forever. Not really, but like theoretically, right?
Hmm.
So how would you put it into the calculator then if I were to do this?
Second vars. And is it normal CDF?
Yep.
The lower would be 85.
Okay. 285, you mean?
Sorry, yeah, 285.
Okay.
The upper would be considered infinity technically, right?
Yes. So I'll just put like 1,000,000 days, right? How about mu and sigma? What number should I plug in? Instead of 0 and 1, I should plug in.
The mean is 278.
Okay.
And then sigma,
Standard deviation, yeah.
9.5.
9.5. Just by looking at the picture without calculating it, what do you think? Do you think it'll be more like 30, 40% or like 60, 80%? Just by looking at the picture.
Like 40%.
Or something like that. Because the entire thing is 100%, right? Like this is less than half, so
And
that's
then
my
the
guess.
middle is like 50%.
Correct, exactly. So good.
Okay.
So normal CDF.
And it's about like 0.23. Or no, 0.231.
Okay, so it's about 23%.
Okay, that makes
Cool.
sense.
Okay. So we kind of guessed. We slightly overestimated. I thought it was gonna be like 30%. But my graph is not to the scale, so. All right. Any other questions on the normal distribution part? How about, wait, hold on. Yeah. How about if the question was something like this? I'm making up a question. If you're, let's say, 90th percentile, what was the length of the pregnancy? What was the... Again, 90 percentile means your pregnancy was pretty long, right?
Yeah.
Your
You can-
90% is lower than you and you are like basically top 10% number percentile, right? So some questions are going to be like, oh, they gave you the percentage, right? and they ask you to find like, are you here? What day? How many days? Are you like 300 days? Are you 297 days? Right? So this is type of question where they gave you the percentage and they ask you to find like, what is your score? How many days was your pregnancy? You see how it's like an opposite question? Before they gave you how many days, 285 days, and they ask you to find the probability, which is basically the area. This question, they gave you, what if you're saying, oh, you are 90 percentile. What was your pregnancy? Length of your pregnancy? Well, this is like a backward question where percentage is given and you're trying to find the score. So here, I'm gonna make a comment here. So the comment is percentage is given where you're trying to find, we are trying to find the score. The numbers in the bottom is called score, like Z score, right?
Mhm.
So in this case, I'm gonna do, okay, 90% is probably somewhere here. I don't know exactly how many days because it's like 90% this way, right? This case, I'm gonna use the function key inf norm. Inverse means like a backward, right? So this is like a backward question. Like you already gave me the answer, it's 90%. But here, you're trying to find what the question was, right? So inf norm, when you go to the inf norm, here, where's my calculator? Oh, here,
You have to switch the
yeah.
percent
Screen.
to 0.90.
Okay, so here, so I'm gonna go to second distribute inf norm. Area should be 0.9, right? 0, it's 90% to the percent. Mean was, the average was how many days? 278. And the standard deviation was 9.5 days. And then I picked left because my graph was going towards the left, right?
Mhm.
So this is the area to the left. And then it's 290 days. Okay. So I have an idea of where to draw the line. That's 290 days. So I'm gonna, so it was 290 days. So it should have been like here. My scale is pretty not good here. Oops. So it should have been like here, not here.
Professor, I have a
Yeah,
question.
yeah.
For the calculator,
Uh-huh.
I do the inverse norm.
Mm-hmm.
Yours, it gave the option of left. Mine's that up.
Yeah, so some of you
Mine as
guys
well.
don't have, so here, yeah, I'm gonna make a note here. If you don't have the center option for TI-84 for inv norm, that means you got the ghetto. I'm just kidding. That means you have the older version. That means you don't go to downtown LA and buy your calculator. Just kidding. That means
shade.
you
It
can
better not be
only
good. It was a lot.
do left by default.
So
Just
what
kidding.
happens if it requires right?
You can always translate into left. So for example, if I want to do, let's say middle 90%, right? If I don't have a center option, that's fine. I just do one more calculation and that's it. That means if I have 90% in the middle, that means I have 10% like left over, right? Because everything has to add up to 100%. That means 10% is in both tails. That means each tail gets 5%. You see that?
Okay.
So in order to calculate this one, I have to do inf norm 0.05 and blah, blah, blah.
I see.
Yeah. So instead of doing 90 and center, I just have to
Which
do 0.05 and it'll just do it for us. It
Okay.
only does center. So like every center question, I can convert that to left question. Do you see what I mean?
Got it.
So it's weird, but it just take extra step. And this point will be inf norm. Basically, you're gonna get the same answer, but 0.95 and blah, 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 blah. Because 0.95, because this whole area to the left will be 90 plus 5, so it's 95%.
Got it.
So it's going to be a little weird, but we can still figure it out. So you'll be okay.
Thank you.
Okie dokie. All right, then. I will release the quiz, and it's due. You have 24 hours, so you have until tomorrow this time to do it. Okay?
Thank you, Professor.
Yeah. And I'll update you with new assignments and home exam. And somebody asked for Did somebody ask for anything? No. Okay.
Professor, actually, one quick question I did have and everything. Just a quick tip. Can you hear me all right?
Yeah.
Okay. If I'm inputting, like, say, I got, I'm inputting the data into my calculator into like one of the columns, and say like, okay, for this person or like people of 38 age group,
right,
answered 0 8 times. Is there a faster way to putting like 8 instead of hitting like putting like 5?
Oh, I see.
10 times?
You want to do, okay, that's a good question. This is back in to calculate like mean, median, and the mode and stuff, right?
Yeah.
So here,
because I used to just be doing seven, enter seven.
Yeah. So you could. So this is question about like inputting data into your calculator. So let's say, for example, today's data, right? Let's say today's data, we have, who was the youngest person again? It was 18, right? How many people were 18?
Just one person.
Just one. So just one. So I can do is I can use 2 columns. First column will be like the actual data. And the second column is how many people have that, like frequency. And then second person was 19. How many people were 19 years old? Like, was it 6 people? I don't remember.
It was 2 people.
Two.
That up right now.
Okay. 2. And then 20. I'll just do 4 numbers just to demonstrate the point. How many people were 20 years old?
Wait 1 second. Where did that screen?
Yeah, I don't remember much. Actually, I do know.
I'm bringing it all up right now.
I think 2 people were 20.
2 people were 20. How many people were 21? Wasn't there 6? I think I remember that.
Oh, that's right. You had that screen.
No. So I just made it up, whatever, right? So instead of typing in 21, 21, 21, 21, 21, 21, 21, I did 21 and then 6. Wait, can you see the screen okay? No.
No.
I can't see your screen.
Oh my God, because I didn't share it, because here. I was like, how come he can't see anything? Because I'm not projecting it.
I'm sorry about that. Okay.
No, it's my bad. Here, sorry. So I went into the edit, L1 and L2, right?
Mm-hmm.
So instead of typing in 21, 21, 21, 21, 21, I did 21, and the next column I put 6. So L1 is actual age, and L2 is like frequencies, how many people have that age.
Oh, okay.
So if it's like 100 people that's 21 years old, I'll put 100 here, right, instead of 6. So when you calculate, so this is basically like a frequency table. You have your data and your frequency means how many people have that. So one person is 18, 2 people are 19, 2 people are 20, 6 people are 21. You see that? Mm-hmm. And when you calculate the average, when you go to calculate, you just have to tell them, normally I'll leave the frequency empty. But here, once you have frequency table, I'll put it as L2. And then it'll know that you want 21 people who are, 6 people who are 21 years old. So that'll make things easier.
That's exactly it.
Okay. That's what's going to happen. Cool. All right. Okay, then. Here, let me share this. Stop the recording.